Hi guys, remember how I told you last time that I wasn't going to teach you how to do powers when we have a fraction? Well, I lied to you. We're going to do that this time, but again, we will explore this a lot deeper when it comes to Algebra 2. Today's just going to be a glimpse over. I'm going to teach you how to double check everything on your calculator. Before we get started, I should also mention I have a guest with me. My sister-in-law is here. You cannot call her by her first name. Her name is Miss Faylor. So everybody say, hi, Miss Faylor. They're saying hi right now. You can't see them. She's smiling at you. Okay, let's just go over some basics that you should know. If we have 9 and we take the square root of 9, I'm going to ask my sister-in-law, what's the square root of 9, Miss Faylor?
3.
Good. I'm going to call her Mary, but if you ever meet her, don't call her Mary. Now, another way of rewriting that is 9 to the 1/2 power, okay? The square root is a power of 1/2. I'll talk about why in a little bit. So, Mary, if the square root of 9 is 3, what do you think 9 to the 1/2 is if it's the same thing?
3.
See how smart she is, guys? All right, Mary, what's the square root of 36?
6.
6. Very good. So what would 36 to the 1/2 be?
6.
6. Very good. The other ones we're going to have to use our calculator, okay? We won't make Mary answer those because if I can't do it, well, none of us can, okay? Square root of 15, approximately we'll just round 3.9. That's why there's approximate symbols. I think, what did Mr. Lankus call them? I think he called them squeakles, right? They're approximate squeakles. The square root of 24, 4.9. And what they're trying to just emphasize here is that a 1/2 power means the same thing. So 15 to the 1/2 is going to be 3.9, and 24 to the 1/2 will be what, Mary?
4.9.
4.9. And remember, guys, like Mr. Linkus would call that, that's a squeakles. But just so you know, in the keystones, you're not going to hear the word squeakles. You will see the symbol, and it will be the symbol approximate, okay? But squeakles is more fun. As we move on, we're going to make sure that we can indicate different parts of a radical, okay? You see this entire thing? That entire thing is called a radical. A radical is made up of 3 parts. The radical is made up of the radicand. The radicand is the number or the variable or the stuff inside. If you need to define that, write it down and pause the video. The index is the number that's in the square root little archy. I should make a note though, if you don't see an index, write that down. Don't see an index. It's an implied 2. We'll talk about that later. Okay, but usually there will be a number here. If there's not a number there, it is an implied 2. I'll draw an arrow in case you're confused. The radical sign is the actual check mark sign. It's just the sign, like a plus sign, okay? Now again, the whole thing's a radical. The inside is a radicand. This number right here is the index, and the little check marky is the radical sign. All right, isn't that radical? Funny, huh?
That's pretty hilarious.
Thank you. Okay, problem 1. What is the simplified form of each expression? So what we're going to do, guys, is I'm going to teach you how to rewrite this stuff in the other form that you saw. Okay, remember from section 7 something before this? I think it was in 7.2 maybe even 7.1. 7.2, it was in 7.2. Do you remember how I would give you like 125 to the 1/3 power, and I would tell you, we'll do this later, I'll teach you what that means. This is exactly where it comes from. Do you see this number right here? That 3 is what we call the, Mary, do you remember what it's called?
Index.
That is correct, and the 125 is called the?
Radicand.
Radicand, very good. The radicand is the actual number. The index, look where the index goes. It goes in the bottom of our rational exponent, rational being fractional exponent. Now you might be wondering, where's that 1 come from? That 1 comes from the hidden exponent that 125 is to the power of. So since 125 is to the power of 1, we do 125 to the 1/3. Now, let's type it in our calculator. Now remember, my calculator's a little older than yours that you use in class, but if you use, remember, we've taught you how to do this on your smartphones, we taught you how to do this on any calculator that you have. You do 125 to the 1/3 power. There, let me make that what it should be. And we get a 5. Now, why in the world would this equal 5? Well, you're asking yourself, what times itself, what's the index in this problem?
3.
That's right. You're asking yourself, what times itself 3 times is 125? Well, 5 times 5 times 5 makes that 125. So if we're asking what the cube root of 125 is, that is a 5. These will get more difficult if it seems easy now. That's because I put the easy problems at the beginning. Okay, letter B. Put a 16, put a power of 1 on it. Let's rewrite it as 16 to the 1/4 power. The 1 comes from the exponent. The 4 comes from the, what's that called, Mary?
Index.
Index. And the 16 is called the?
Radicand.
That's right. So you're asking yourself, what times itself 4 times is 16? I'm putting Mary on the spot. Do you know what it times itself 4 times is 16?
2?
2 is correct. Because 2 times 2 times 2 times 2 is 16. 2 is our answer. But let's say that, oopsie doopsie, you forgot that. 16 to the 1/4 power is a 2. And I'm going to be giving you guys a list of perfect fourths, perfect fifths, perfect cubes, perfect squares, so that will be a little easier. You don't have to memorize everything, although you probably should. All right. That's going to be 27 to the 1/2. Mary, how else could I rewrite this?
27 to the 1/3 power.
That is correct. And Mary, I would ask myself what question. I would say, what times itself
3 times
equals?
27.
Mary, do you know what times itself 3 times gives you 27?
3.
That is correct, because 3 times 3 is 9, times another 3 is 27. See, guys, she can get it. She's been out of math for, I'm not going to tell you because then you know how old she is, but she's been out of math a lot longer than you've been in math, so, sorry, Mary. So, you can do this if she can do this. Mary, what power would 32 have on it?
1/5.
That's right. Mary, do you have any idea what times itself 5 times is 32?
2.
Yes, that is correct. If you know 2 to the 4th is 16, an extra 2 would make 32.
That makes sense.
See how smart she is, guys. All right, now we're really testing her knowledge here. Mary, how would I rewrite part C? This is what we call in radical form, because it has a radical symbol. We're going to write it as an exponential fraction. Mary, how else could I rewrite this thing? The same way we have been rewriting it.
64 to the 1/3.
Yeah, that's correct, because 64, hold on, 1/3. 64 has a power of what, Mary? Inside the radical.
3.
It has an index of 3, and it's right, an exponent of 1. Mary, do you know what times itself 3 times is 64?
3. 4.
4 is correct, because 4 times 4 is 16, times 4 is 64. But if you forget, pull out your handy dandy. What was it, 3? And you get a whopping 4. How exciting. All right, last one, Mary. How could I rewrite part D?
36 to the 1/2.
Now, you guys see this? The 2 does not have to be written there. This could be hidden, okay? If something is not there, it is a 2. Everybody understand that? Good. So even if it wasn't there, it's a 2. But look how nice the book was. They actually did write it there. That could be written as how, Mary? 36?
To the 1/2.
And what times itself 2 times gives you 36?
12.
Blank times blank is 36. You did up here. Oh, she's got a brain fart. Don't worry, they get brain farts all the time.
6.
6! She's got it. Alright, moving on. That was a lot of fun, guys, wasn't it? Good job. They're going to get harder, so don't get too excited, okay? They're going to get a little bit harder as we move along. Okay, I would prefer not to teach you the way the book teaches you, but rather to teach you the way that I like. So let's just go on to the next problem. And actually, no, I want to try some ourselves. That's right. See, I put my little reminders here so I can remind myself. It'd be helpful if I kept my answer key where I should keep it, huh? All right, here's how this problem is going to work. Are you ready? All right, we are going to practice rewriting stuff. Here we go. If I give you, and this is just going to explain what they have up here, except I'm going to make it easier, okay? If I have b to the 7/8, if I draw a radical sign, Mary, do you know where the 8 goes?
In the
Check marky thingy. That is correct. It is called the index. This 8 is the index. Don't get that confused, guys. The b is called the
radicand.
That is correct. We put that inside. And the 7 is simply the exponent that belongs with that b. Okay, so we're just practicing rewriting for right now. Okay, practicing rewriting. These are going to get more difficult, but we will break it down as best as we can. Let's just try one. You know what? No, that's good enough. We could rewrite this, put a big fat or here. I'm going to teach you another way that could be written. I personally think that's the best way. but you may see the book rewrite it like this, where they take the whole entire 8th root of b and make it to the 7th power. Okay? Now let's practice some other ones. Here we go. This will be great. Look at part A. Part A says, what is 12a to the 2/3 in radical form? Now what you should notice is that this is currently in exponential form. That's all I wrote there. Let me move it over so you can see it. That is currently in exponential form. They want us to put it in radical form, which simply means they want a little checky mark thingy, okay? Now, the only thing that has an exponent is the variable what, Mary?
A.
A. The only thing that has an exponent is the A. You guys, please do not make the mistake of thinking that this exponent goes with the 12. Write that down because I saw that in some of your homeworks. You guys think that just because there's an exponent over here that it applies to the 12. It doesn't. The only thing that has the exponent is the what, Mary? The
A.
A. The only thing that has the exponent. All right, the 12 goes on the outside, everybody, and then we write our radical sign. Now let's see. Mary, do you remember the I word that this 3 is?
Index.
That goes right here. And you remember the R word?
Radicand.
That's right. A is the radicand. And that is the just simply exponent. Yes, of A. That's as good as it gets for this particular problem. Could we write this differently? Absolutely. We could write it with a 12 and then the cube root of A, and then you could put parentheses around the cube root of A and put it squared. But that's really ugly. This is the prettiest way of doing it, okay? Now the next one, you notice I saved a lot of space. That's not just because, I made a mistake. It's because this problem is hard, so keep it organized if you want to understand this problem. In this particular problem, Mary, do you see a pair of what here?
Parentheses.
That means that that exponent goes both to the number and to the variable. So this is going to be 64. What's that power there, Mary? Can you read that? That's right, 4/5. So 64 is getting this. You guys were wondering why we studied 7/3. That's because this makes no sense without us studying 7/3. And this would also be a to the what?
4/5.
That's right. Now, what I did is I probably made it a little, I didn't need a parenthesis there. Probably made that a little more difficult, but I really wanted you to see that it went to both of them. Okay, everybody? All right, guys. What we got to do now is we have to remember what root we will be looking at. Do you guys see the index here? Can you write that the index is, Mary, what's the index on this problem? It's the
5.
bottom. Very good. The index is 5. Now, it's very important that we recognize this fact, because we have to look then, so we'll say, so look at the perfect 5th power sheet that I gave you. So look at the perfect 5th powers. Now, I don't have mine on hand, but you guys will have yours because I should have given it to you when I gave you the set of notes. Can anybody find, ready? And here's your next step. Find a perfect 5th that goes into 64. Now, when you go to your 5th list, you should see the very first 5th is 32. Because 32 is 2 to the 5th. Okay? So here's what we're going to write. We're going to indent again. 32 is a perfect 5th. Okay? And it goes into, it's getting mushed together. It goes into 64. Be patient, because there's how we're going to rewrite this. Do you see this problem? We're going to rewrite it like this. Rewrite this problem as 32, give it a space, times 2, a to the 4/5. Now, you might not like what's about to happen, but you're going to have to deal with it. Try to make sense of it. Because this power was for all of 64, I made it 32 times 2 Because what is 32 times 2, Mary?
64.
Because 32 times 2 is 64, that is why I picked 32 times 2. Why did I pick 32? Because 32 is the perfect fifth. Why did I look at my perfect fifth list? Because the index is 5. You really got to do a lot of thinking with these. Again, because the 4/5 was with all of 64, you must put it with the 32 and you must put it with the 2 because they are both part of the 64, and the 64 had a power of 4/5, so both parts of it gets a 4/5. A lot just happened on this problem. It just got really intense, didn't it? You want to go back to problem 1, huh? What we're going to do is we're going to put a box around these two. Those two are just going to hang out inside a radical. The index is what, Mary?
5.
That is correct. 2 is going to go inside, and 2 is going to have this power. What was its numerator, Mary?
4.
It's going to be 2 to the 4th power now. And Mary, what do you think A is going to be?
A to the 4th power.
That is correct, because I would still have my 4/5, 4/5. Now what we're going to do is, you see this 32 to the 4/5 power? We're going to get our handy dandy. And watch how pretty this is going to be. 32 to the 4/5. It comes out as a nice, clean answer. It comes out as 16. I can explain in further detail why it comes out as 16, but I think you guys are handling enough right now that that's good enough. Now you might say, well, Mrs. L, why didn't you just do 64 to the 4/5? Well, watch what 64 to the 4/5 is. It's crazy, right? So that is why I had you go to that perfect fifth list, or perfect fifth power list, and find that 32 is the number that we actually needed, so we could get a pretty little answer. And it goes outside the answer because we could take the root of it. That was fun. Mary, was that fun?
Let's do it again.
Okay. Oh, I like this. Oh, good. Somebody who wants to learn.